Hello everyone. Today we'll talk about the solution to the problem minimum number of swaps to make the string balanced. Whenever we have a problem about balanced sequences of brackets, of parentheses, there are two ideas that will typically come to mind. The first idea is a stack, because they can be often modeled as a stack. And another, which is common when we have, as in this case, only a single type of parentheses, is this mountain view sort of interpretation, where whenever you see an opening bracket, you go up. Whenever you see a closing bracket, you go down. Every bracket you also step one step to the right. And for instance, in this representation, the bracket is correct when it starts at 0. Of course, it should start at 0 every time. It ends at 0 and never dips below the line. And that would be, in this interpretation, a correct definition of a balanced string of parentheses. So, how do we use this interpretation, this diagram, to solve our problem? Well, the two things that we have to ensure to have a balanced sequence is that it starts and ends at the same spot, and all the mountains are above the ground level. The fact that it starts and ends at the same levels is guaranteed because we have the same number of opening and closing parentheses, and our swaps will not change parentheses type. So the only thing that we have to care about is that we never dip below the ground level. Of course, we know that it's possible to always create a correct bracket sequence. We know that we start and end at the same position, and it's possible to just make by sorting, so just sort all the brackets so we have all the opening ones to the left, all the closing ones to the right, this mountain shape. So that's always possible, but of course it's typically not optimal. And it's easy to notice that since there is no point in swapping two opening brackets with each other or two closing brackets with each other, it doesn't change anything. And it's also not useful to take an opening bracket and a closing bracket to the right of that opening bracket and swap them together, because our swap operation will change, so it will take two segments and swap them together, which means that the portion between those two segments will be either lowered or it will be greater, right? It will be taken higher. And of course, you want to be as high as possible all the time. So that means that if you have, for instance, a bad situation, 2 up, 2 down, 2 down, 3 up, 1 down, and we want to fix it, then we want to fix it by changing the first step of going down with the last step of going up. In that case here, we reach the height of 2 and suddenly we reach a height of 3. And we don't have 4 steps downwards because this height was minus 2. We only have 3 steps downwards, so we reach 0. That's still okay. And now here we had 2 steps up, so we go 2 steps up. Now we have this segment. This segment is exchanged for a downward segment, down, down. So we can see that we're able to fix this dip of minus 2 by just making the exchange of a single pair of parentheses, because that pair, this closing one, instead of making us go down, it makes us go up. So it changes our height here at the lowest point by 2. And so that means that we have to just calculate the deepest that we've ever been and divide it by 2, rounding up, and this is the number of swaps that we require. And of course, it's not like all the swaps will appear, let's say, immediately before this dip, but again, by taking the leftmost and the rightmost wrong parentheses, we make the area of influence as big as possible. And of course, that also means that we'll always fix the first dip below 0, because for us to go below 0, we will have to have a closing parenthesis, so it's either the leftmost closing parenthesis or there is an even earlier one which will raise this point, because here we have an opening one. Anyway, this is essentially the details of the strategy, but we don't need that strategy. We just have to calculate the deepest depth that we've ever been at. So we'll be maintaining that as a variable and maintaining the current depth. We start at 0. And whenever we see an opening or closing parenthesis, we adjust this value. So here I took a convention that an opening parenthesis reduces that and a closing one increases the value. So this is essentially our deficit. We'll be keeping the biggest deficit we've ever seen and of course at the end we take it divided by 2, but round it up. And of course, as a mathematical note in integers, when you want to divide by p but round up, then a divided by p, that's the same as a plus p minus 1 divided by p rounded down. This is a useful trick.